Alright, so let's keep looking at mods. In particular, in this short video, I'm going to talk about 10, 5, and 2. So again, let's look at a definition. So this definition reads, A is congruent to B mod M, means if you divide A by M, the remainder will be B. So this triple equal sign, this is what we mean by congruent. So that's our symbol to say that we're not saying two numbers are equal. We're just saying that they have this relationship of congruency there. When I divide by M, I'm looking at what my remainder is. And remainders always have to be less than the number I divided by. All right, so let's look at that and be able to explain that better. So let's start with 10. So in mod 10, my smallest remainder would be 0. And then the largest could be would be 9. So 0 through 9, including 9, those are my answers I'm allowed to have. None of the answers are negative, and all of the answers are less than 10. Okay. So let's say I start with 12. 12 mod 10 is 2. What this says is if I were to divide 12 by 10, so let's do old school division, it would go in one time, which means I would have 10 here, and when I subtract, I get 2. Okay, there's my 2. So same thing, but if I had 27 mod 10, well, same idea. I could say 10 goes into 27, and it would be 2 times, which gives me 20. And when I subtract, I get 7, which is my answer. Okay. Luckily, mod 10 is super easy. This number 2 in the ones digit is the 2 in the answer. This 7 in the one digits is the 7 in the answer. So you should be able to see that 148 mod 10 is just going to be 8. The ones digit is the ones digit. You don't have to do the division when I'm doing mod 10. Mod 10 should be easy. So let's do some more examples. If I have 34 mod 10, the answer is simply 4. 155 mod 10, the answer will be 5. 178 mod 10, the answer is 8. So I'm just taking the one unit, the ones digit in each of the cases and saying that's my answer. So if I were to get bigger and try to add some numbers together, say I had 36 and 142, I'm not going to actually add the numbers. I'm going to say 36 mod 10 is 6. 142 mod 10 is 2. 6 plus 2 is 8. Done. So let's try another mod. Let's do 5. It's also an easier of the mods to talk about. In mod 5, our answers, my smallest remainder could be 0, my highest could be 4. Okay, so let's look at 15 mod 5. Well, when I do 5 into 15, I get 3. Nothing left over, so that means my remainder is 0. Important to make yourself think in remainders. That'll be a new thought to you, but make sure you do make yourself think that different thought. Just don't do division. Okay, so 28 mod 5. Let's write that one out just to show you what we're doing. So here's 28. And I'm dividing by 5. So 5 goes into 28 5 times, which gives me 25. This remainder of 3, this is my answer. Okay, so it's not as simple as just looking at the ones digit. There's a relationship we will talk about in a minute, but there is that, think about what's the remainder. Okay, so here's another one, 13 mod 5. Again, I would have 3 left over if I did 13 divided by 5. That would give me 2. That makes this 10. And my answer would be 3. This 3 is this 3. Okay. So what if I had 42 mod 5? Can you see that that would be 2? There's kind of this thing that's happening here. If the number is less than 5 in the ones unit, I just write it again to 2. If it's bigger, 8 minus 5 is 3. 5 minus 5 is 0. So I do have a relationship similar to 10 that I can use here. So let's try some new ones. And here's a new thought I want you to put in your head, because anytime we talk about money, I think this becomes easier for you. So pretend you're a teller at a bank or maybe a cashier at the store and you're having to give change. And you're trying to give this much money back, 27, 111, 39, 86. Think about how many $1 bills are you going to give, ideally. You're not trying to give somebody 27 $1 bills or 111, right? That just doesn't make sense. So think about how many dollar bills do you know for sure you're going to have to give this customer. And I want you to think about that as your way to answer these questions. I think that will make mod 5 easier. You may want to pause, give yourself a couple minutes to try this, then come back and check out the answers with me. Okay, so here's what I see. If I'm giving somebody $27, I know there's going to be 2 $1 bills. If I'm given $111, I know there's going to be a $1 bill. If it's $39, there will be 4 $1 bills, or if it's 86, I will give $1 bill. This is my same idea as mod 5. It's how many ones would I have when I'm giving back a change. Okay, so let's do a couple more. Let's say I had 10 mod 5. You see there's 0, 5 goes in evenly into 10. Alright, so I'm going to use that to connect what do I do with negatives. So notice I'm keeping that 10 that I just had here, but now I'm adding negative 7 to it. So I'm going to do normal addition. Negative 7 plus 10 is 3, and there's my answer. So again, let's try that. 25 mod 5 is 0, and I'm going to add that 25 to negative 23. So here, negative 23 plus 25 gives me 2. Okay, so that's my hint of what do I do when I have a negative? I add a multiple of the mod. A negative, add a multiple of the mod. So say this time I give you negative 42, I'm going to have to add a multiple of 5. But I want this multiple of 5 to be bigger than 42, that way it'll cancel out the negative. So I'm going to choose 45, which is 9 times 5. Negative 42 plus 45 gives me 3. That's my answer. So say I had negative 18. Think about multiples of 5, 5, 10, 15, 20. 20 would be bigger than 18, so when I add it, I get 2. It's really important that you're picking a multiple of 5. You're not just picking some random number. So I couldn't add 19. I can't add 21. It has to be 20. It needs to be a number that when I multiply it by 5, I have no remainder. Okay, so let's talk about mod 2. Mod 2 only has 2 answers, 0 and 1. Either 2 goes into it evenly, I have no remainder, or it doesn't go in evenly and I have a remainder of 1. So it's even odds. Evens will all be 0. Odds will all be 1. So these should be super easy. 32 even, so it's 0. 327 is odd, so there's 1. 48 and 51. Break this down. 48 is even, so that's a 0. 51 is odd, so that makes it 1. 0 and 1 is 1. Okay. A few more examples. Let's do another mod 2. Let's say I have negative 7 mod 2. Well, just like with 5, I had to do a multiple of 5. With 2, I do a multiple of 2. So a multiple of 2, I'm thinking 8. So if I add negative 7 and 8, I get 1. So how about you try this one? What's negative 19 mod 2? Well, think about what's a multiple of 2 that's bigger than 19? I think of 20. So if I have negative 19, I add 20, I get an answer of 1. Alright, so here's some more U-tries and a bunch of them. So I do want you to pause the video, write these all down, and try to answer them, and then come back, check your answers with me. Okay, so let's start with 4 mod 10. This 4 is positive, and it's less than the mod, so nothing happens. It stays as 4. 22 is a perfect multiple of 2, and it's even, so it's 0. 8 plus 7. I need to add 8 and 7, which gives me 15. 15 mod 10 is 5. Remember, I'm back to the 1 digit. 9 plus 14. Well, 9 plus 14 is 23. And remember how we talked about giving change? I would have to have 3 ones, so this is a 3. 600 plus 191 mod 2. I'm not looking for you to figure out anything hard here. Mod 2, remember, it breaks down to evens and odds. 600 is even, so that's 0. 191 is odd, that's 1. 0 and 1 is 1. Negative 83 mod 10. Well, when negatives, I need to add a positive multiple of the mod. So a multiple of 10 that I could use would be 90, because that's bigger than 83. 90 plus negative 83 gives me 7. And the last one, negative 67 mod 5. I need to add a multiple of 5 that's bigger than 67. Luckily, think 510, 510. So since this is 67, the next thing bigger will end in 0, so I think 70. Negative 67 plus 70 is 3. All right, make sure you come back and check out the next video where I'll do some other mods, so not 2, 5, and 10. We'll do some 7 and 4 and just different numbers like that.